Well, good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Picard. And we're going to be working with solving quadratics by graphing. So we're continuing along with quadratic functions again, like I said we would. And a little shout out going to all my alpaca wearing people out there. You know who you are. So 5.2, section 5.2, solving quadratics by graphing. This is a quadratic equation. Basically, the big thing here, the only really change is instead of having an f of x or a y here, we got 0. So basically y equals 0. Now what we're going to do when we're graphing these is make sure everything is equal to 0 like this and then plug the y back in. So the way we'd rewrite it is y equals, and I'm just flipping the quadratic function here around, ax squared plus bx plus c. And once again, the y you're saying is equal to 0. So, and that'll come into play later. We'll talk about what y equaling 0 is when we're solving by graphing. Here it is. Your solutions. You have one real solution, two real solutions, or no real solutions. And it depends on how many times it crosses the x-axis. And here's y. At this point right here, I'm not sure what x is equal to, but I know what y is equal to. Y is equal to 0. So when we're working with y equals 0 up here, if we want to find our solutions, we want to find our solutions when y is equal to 0. And that's only when it crosses the x-axis. So you can see here, we're going to have two solutions. And this one over here never touches the x-axis. This one also never touches the x-axis. Neither one of those would have a real solution, so no real solutions. So basically when we're solving these quadratic functions by graphing, we're looking for the points where it crosses the x-axis. They're very important. Two solutions. Most of the time they're going to have two solutions because it's x squared term. If it was just x to the first, no x squared term, we'd have one solution. Ooh, I wish I had some alpaca coat on right now. I'm kind of cold. Find the following and then graph. Then state where the zeros are located. So basically, we're going to graph this. Now, I'm going to say this: y is equal to 0. So I'm going to replace this 0 with y. Y equals x squared plus 6x plus 8. So tell me what you know. You guys know what the y-intercept is. It's 8 right here. If you plugged in 0 for x here and here, you get 8 for your y-intercept. Our vertex and our axis of symmetry, we're going to work with this formula. X equals, you got it, negative b all over 2a. So the opposite of b would be 6, or I'm sorry, negative 6 all over 2 times 1. Negative 6 over 2 is equal to negative 3. So right now, vertex, negative 3 something. Axis of symmetry, I know is x equals negative 3. Anyway, I'm going to go over here and throw in a beautiful little axis of symmetry here, which is x equals negative 3. To find the rest of my vertex, we're going to plug that negative 3 in for x up here. I'm going to say y equals negative 3 squared plus 6 times negative 3 plus 8. And I'm going to end up with 9 minus 18 plus 8. That's basically 17 and negative 8 are negative 1. So negative 3, negative 1. Here is negative 3, negative 1. Here's our vertex. I know my y-intercept, 6, 7, 8 is right about here. Now that's 1, 2, 3 units away from the axis of symmetry. So 1, 2, 3 units over here. What I want you to get used to is putting in a couple more points. Now I know we have negative 3, negative 1. That's your vertex. But plug in negative 2 and negative 1. A couple points, one more than x and another one, and 2 more than x. If I plug in the negative 2 and the negative 1, that'll give me enough to get a good graph here. So basically I'm going to plug negative 2 in for x right here. So y equals negative 2 squared plus 6 times negative 2. Was it plus 8? I'm going to be careful. I don't want to get over too far. So that's 4 minus 12 plus 8. That's equal to 0. So guess what? There's our first 0. Because y equals 0. Negative 2, 0. Now I have another point on the other side right here. So that's where my graph crosses the x-axis. So those are my zeros, negative 2 and negative 4. So basically done with the problem. I do want to put in negative 1 also though, right here and right here. So I'll say y equals negative 1 squared plus 6 times negative 1 plus the 8. So that's 1, I'm sorry, minus 6 plus 8. That's going to give me a grand total of 9, and negative 6 is negative 3. So negative 1, it's positive 3, isn't it? Yeah. Negative 1 up 1, 2, 3. So if I got a point here, 1, 2, 1, 2. I have a point right here. So my graph not the best parabola, but it is graphed. And we found our zeros. In other words, we found our solutions. Zeros and solutions are basically the same thing. They call your solutions where it crosses the x-axis zeros. Or solutions. They call them zeros because that's where y is equal to 0. That's where it crosses the x-axis. And they're also our solutions. So my two solutions to this problem are negative 2 and negative 4. So if I ask for zeros or solutions, I'm asking for the same thing basically. Okay. And we're going to do this one right here. It says find the following and then graph, then state where the zeros are located. Okay. Well, first of all, we got to get everything equal to 0. So I'm going to subtract 16 from both sides. So putting this in order now, it is basically negative x squared plus 8x minus 16 equals 0. Once again, if you want to solve for this, you got to set y equal to 0 so you can graph it. And all I do is flip the equation. Now we can graph it because it's y or f of x equals our function here. Our solutions are going to be where y is equal to 0 right here. So basically we're looking for roots, zeros, solutions, whatever you want to call them. Y-intercept, negative 16. It's not even going to be on the board, so I'm not too worried about it. My vertex is going to be, okay, x equals negative b all over 2a. So we got negative 8 all over 2 times negative 1. So we got negative 8 over negative 2 or 4. A couple things. My x value, my vertex is 4, and my axis of symmetry is x equals 4. So right through here. Plugging that 4 in for x, I get y equals negative parentheses 4 squared plus 8 times 4 minus 16. Now, if you look at this x right here, x squared actually, it's negative x squared. The negative is not squared. Only the x is squared. So it's negative 4 times 4 is 16, so that's negative 16. Plus 32 minus 16. That is equal to 0. So, well, that's kind of nice. We just found our solution. 4, 0 is right here. I know it opens down because it's a negative x squared. So I guess we're done, but I do want to graph a few points. I want you guys to get used to this, x and y. My vertex is at 4, 0. So we're going to plug in a couple points less than 4 or more than 4. I'm going to say 3 and 2. If I plug in 3 for x in my equation right here, I'm going to get y equals negative 3 squared plus 8 times 3 minus 16. So that's 3 squared. That is 9. 9 times this negative 1 right here is negative 9 plus 24 minus 16. Oh, what is that going to equal? That is going to equal negative 25, negative 1. Okay, so it's 3, negative 1. So over 3 and down a negative 1, I have a point on the other side, 1 unit away. So once you get 1 point, you can graph the second one on the other side of the axis of symmetry. Negative 2 squared plus 8 times 2 minus 16. Well, this is 2 times 2 is 4 times this negative is negative 4 plus 16 minus 16. Well, that's negative 4. So here's my other 2 points. 2, negative 4 is right here. It's 1, 2 units away, so I go 2 units over. And that's all the points I need to graph it. And voila. There we go. Zeros. How many zeros are there? There's only 1. If the vertex is what crosses the x-axis, you only have one solution, 1 0. So 4. 4 is our 0, or our solution. Okay. Let's see what the next one is. I think I'll let you guys work on this one. Try this one. We'll look at it tomorrow in class. I want to go to the next one here. This one. Okay. In 1999, Adrian Nicholas broke the world record for longest human flight. He flew 10 miles from a drop point in 4 minutes and 55 seconds using an aerodynamic suit. Using the information from the diagram, ignore the air resistance, so we don't care about air resistance. How long would he have been in free fall had he not used this suit? Use the formula. H of t equals negative 16t squared. Remember, negative 16 is gravity's pull, plus h sub 0, that's the initial height. Where t is time in seconds, and the initial height is h sub 0, yes. H sub t is the height at whatever time you're looking for. Now, basically they're looking, he free fell till he was 500 feet above the ground, and then he pulled out his parachute right here and put his parachute on, so he wasn't free falling anymore. So he started at 3,500 feet, and he free fell to 500 feet. So what this is saying is negative 16t squared, his initial height would be 35,000, okay? You want to find how long it took him to get to the point of 500 feet. So I'm going to put 500 feet as my h of t. That's what I'm looking for. Not my maximum height, but when he was at 500 feet above the ground. So if I want to solve this, first thing I'm going to do is get everything equal to 0. And I get 0 equals negative 16t squared plus 34,500. Okay. Well, I want to solve this by graphing. So I'm going to say y equals 0. And now I'm going to graph this. This would not be fun to graph, and I would not suggest graphing this by hand. So we're going to use our little friend, Mr. Calculator. You should be able to do this on a TI-83 or 84 also, but I'm going to use the TI Nspire. If you have problems with it, I'll work with you tomorrow in class. So we're going to go to graph, and we're going to type in negative 16 x squared plus, where is it, 34,500. And we want to find when this parabola crosses the x-axis. So now I'm going to hit enter. And I don't even see my graph. So what we're going to have to do is go to menu. And we're going to go to zoom window. And I'm going to go down to zoom fit. There's our graph. Now I want to see when it crosses the x-axis here. And I don't think it's even close to crossing the x-axis. So I got to open up my window a little bit. We got a window. Let's go to window. X max, X min. I'm not too too worried about that. I want the Y minimum. Okay, right now the Y minimum is 32,740. We're going to have to make that negative. So let's go just to negative, we'll say 10 at least. And hit OK and see what happens here. Oh boy, now we got to go way out for X's. Let's go to window again. And we don't care about the negative because we don't care about negative time, we care about positive time. So my X max, I'm gonna guess time, let's go 100. See what happens here. There we go. Now I can see where it crosses the x-axis here. When I do that, I'm going to go to menu and I'm going to go to analyze graph and find 0 now. I want to see where it crosses the x-axis. You can see my little hand going there. I'm going to say click here through here and it's going to give me a 0. Where is my 0? Hit enter. Oh, I want to do that. Let's hit the window here again. Analyze. No, window. Let's go to Y minimum, negative 100. Okay, I'm going to have to look at this and get back to you guys. We should be able to find our max by using the graphing calculators that way. But I will look at this with you tomorrow. Goodbye to my alpaca brothers and sisters.